Okay, for my science project, I decided to make a children's book. It explains how our eyes and brain perceive color. And the reason I chose to do this is because I'm a graphic design major, and so I figured that this would be a good way to sort of do the science project and incorporate my major into it. So this is called Why Are Apples Red? On a warm sunny day in July, little Billy Bandpass Filter went for a walk. It was so beautiful outside that Billy decided to stop for a while and look up at the bright blue sky. When he looked up, he saw some red apples hanging from a tree beside him. Wow, those apples look so yummy, Billy thought. I don't think I have ever seen apples quite so red before. And then Billy had another thought. Why are those apples red? Why are some apples green? Why can't they be blue or purple or orange? Steve the squirrel, who just so happened to be scurrying in the apple tree above Billy's head, saw how confused Billy looked and stopped to help him out. Hello, said Steve. You look very confused. Can I help you with anything? Heck yeah, Billy said. My name is Billy, and I just gotta know, why are those apples so red? Oh, that's all, laughed Steve. I can tell you the answer to that. You see, Billy, the reason that those apples are so red is all because your eyes and brain can see color. The apples are red because my brain can see color? Yes, Billy, if you couldn't see color, you wouldn't even know that those apples are red. Well then, how do my eyes and brain see color? Billy asked. Well, Billy, your eyes and brain perceive color through an amazing process, and it all starts with light. When light hits an object, it is reflected back at your eyes. Certain wavelengths of electromagnetic, that's electric and magnetic, waves are light signals that are reflected in light and determine what color you see. Wow, so you're saying that really, color is just a light signal. Basically, yeah, the light waves reflected from an object, like an apple, hit the light-sensitive retina at the back of your eye. Inside the retina are two types of photoreceptor cells that respond to light, called rods and cones. What? Is it good or no?
No, you kept kind of
You're not helping.
You kept leaning slowly this way.
Okay, well, Jesus. Inside the retina are two types of photoreceptor cells, cells that respond to light, called rods and cones. Cones are the photoreceptors that are responsive to color. Rods and cones. Most people have 6 to 7 million cones all concentrated in a 0.3 millimeter spot called the fovea centralis. So here we have the eyeball. This yellow stuff is the retina. And then this is a close-up of the fovea centralis. These are what's called binary cells, and they connect to your rods and cones. And this is where the electrical signals are sent out. So when the reflected light goes through the eye and hits the cones, they are activated in different amounts until they have formed an electrical signal of their own. Then they send this signal through the optic nerve to the visual cortex of your brain. So here again we have the eyeball and the retina, and this is the optic nerve, and right back here this blue section is your visual cortex. And so the electrical signal travels through the optic nerve and into your brain. Once it arrives there, the visual cortex of your brain processes the signal it has just received and returns with a color. And this whole complex and incredible process is all done in a matter of seconds. That's how amazing your brain is. So your eye would see that this is red, and your eye would take this light signal that the apple is shooting at your eye through the optic nerve to your brain, and your brain knows that this signal is red, and so you know that it's red. Geez, that's awesome. So when I look at an apple, it's sending its light signals at me, and my eyes tell my brain what the signals are, and my brain knows that it's red. Wow, thanks, Mr. Squirrel. You sure do know a lot about this stuff. Hey, how do you know all this stuff anyways? You're just a squirrel. Well, gotta go. Nice knowing you. Take it easy, Billy. The end.